Hello everyone, welcome back to Deeksha Vedantu YouTube channel, and you are watching 99% in 99 days. We have already come through a long journey. Today is day 82 of the 99 day series, and we are going to discuss the sample paper 8, right? So we are trying to complete as many sample paper as possible. So in the journey, in the sample paper 8, let's see what are all the question patterns. So we have 6 1-mark question in this paper, we have 2 2-mark question, we have 2 3-mark question, we have 1 5-mark question, 1 4-mark question. I guess the number is same, 10 16 I think 16, yes, 25 marks as usual from physics chapters, and chemistry and bio obviously have the similar number of chapter per marks division. Let's see the section A 1-mark questions in this paper. And before going into the paper, in the sample paper 7 I did one question wrong, that 60 hertz, if the cycle is 60 hertz, the change is basically 120 times. So whatever is the frequency, the change is basically twice of that. So from 0 to positive, from positive to negative, so there is a it is changing its polarity twice. That's why it will be 60 into 2, that is 120 times. Okay, so I hope that clears your doubt that you might have in sample paper 7. Now let's move into question number 11. Absolute refractive index of glass and water is 3.2 and 4/3 respectively. So absolute refractive index of glass, let me change the color. So absolute refractive index of glass is 3/2 and absolute refractive index of water is 4/3. So it is given. If the speed of light in glass is 2 into 10 to the power of 8 meter per second, the speed of light in water is. So we know that Ng is basically speed of light in vacuum divided by speed of light in glass, and in water is basically speed of light in vacuum divided by VW. Now C is not given, you can take that as well, but since we have been given with VG, let's use that. Anyway, you can use C as well, that will also give you a correct answer. Okay, but the process for this problem is not using C, so let's solve it without using C. Okay, so it will be V water divided by V glass, right? So we will put the values one by one and we will see what is the answer. So Ng is given 3/2, so 3/2 divided by 4/3 equals to, we are trying to find in the water, so water is will remain as it is, and in the glass it is given 2 into 10 to the power of 8, right? So from there you can calculate VW to be equals to 3/2 into this 4/3 will inverse, so it will be 3/4 into 2 into 10 to the power of 8. So this two cancels, so it will be 9/4 into 10 to the power of 8 meter per second. So 9/4 into 10 to the power of 8 meter per second. Okay, clear? Now let's move on to the next question. Question number 12. When a beam of white light passes through a region having very fine dust particles, the color of the light mainly scattered in that region is, so if the light which is thin, we know that blue light scatters the most, and if the particle is very thin, which is scattered, is basically blue light. Okay, yeah, red light generally do not scatter too much, and orange is very close to red, yellow is in between, so the light which will definitely scatter will be blue. Okay, red and orange do not scatter too much. Now next question, this is a circuit diagram based question. Consider the following combinations of resistors. So there are two combinations here, 2 ohm 2 ohm, then 3 ohm 3 ohm 3 ohm, 2 ohm 4 ohm, 3 ohm 3 ohm, 0.5 ohm 0.5 ohm. Now what is the question? Combination 1, 2 2 ohm resistors in parallel. Combination 2, 3 ohm resistances in parallel. Combination 3, resistors arranged with 2 and 4 in series and parallel with 3 ohm resistors. Okay, with two 3 ohm resistors actually. Combination 4 to 0.5 watt resistors in parallel. The combination having equivalent resistance of 1 ohm are is or are. So what are the combinations that have 1 ohm combination? Okay. So let's see. First let us find the combination for these two resistances. Okay, two equal resistances connected in parallel. Two equal resistances connected in parallel means we can say two equal resistances of 2 ohm connected in parallel. How many resistances are there? Two resistances are there, all having same resistance, that is 2 ohm. So the equivalent resistance will be 1 ohm. Okay, now this is the case number 1. Case number 2, how many resistances are connected in parallel? 3 resistances are connected in parallel. So 3 resistances are connected in parallel, so it will be divided by 3. And what is the resistance of each resistances? Each resistances have resistance 3 ohm, so each of them has 3 ohm. Okay, so again 1 ohm. Okay, now if you see here we have given 1 and 2, 1, 2 and 3. So only thing that we have to calculate is 3 more. 4 definitely we don't want to calculate. Okay, even though you calculate you will get 0.25, which is absurd. Now let's see the number 3. So number 3 is we have 2 ohm and 4 ohm connected in series. 2 ohm and 4 ohm connected in series means the arm of this resistance is basically the total resistance is 6 ohm. Okay, now what is this? Again 3 ohm, another 6 ohm. So basically you can say in this case two 6 ohm resistances are connected in parallel, right? Two 6 ohm resistances are connected in parallel. 2 plus 4 is 6. 3 plus 3 is 6. So two 6 ohm resistances are connected in parallel. So how many resistances are connected in parallel? Equal. Are they equal? Yes, they are equal. So we can use the shortcut formula. So they are equal, and how many of them are there? 2 are there. What is the resistance of 1? 1 having resistance only 6. So the equivalent resistance is 3 ohm. So definitely only 1 and 2 will have a resistance equal to 1 ohm. So correct answer is option C. If you want to find the resistance, how to calculate? Again 0.5. How many resistances connected in parallel? 2 resistances connected in parallel, and are they equal? Yes, they are equal. So we can simply divide by 2. And what is the value of one resistance? One resistance is 0.5. So 0.5. This is only valid when two or more equal resistances are connected in parallel. Okay, so for example here 2 ohm resistances connected in parallel, here 3 ohm resistances connected in parallel. So it does not matter as long as how many resistances are connected, as long as they are all equal. As long as they are all equal and they are connected in parallel, okay, then the equivalent resistance is basically resistance of one resistance divided by how many parallel combinations are there. So 3 is divided by 3, 4 is divided by 4, 5 is divided by 5, like that. Okay, clear? Now let's move on to the next part. Question number 14. An electric iron of resistance 20 ohm draws a current of 5 ampere. The heat developed in the iron in 30 seconds is, so Joule's law of heating, H equals to I square R T. So I is given 5 ohm, so 5 square, R is given 20 ohm, and T is given 30 seconds. Okay, so it will be 25 into 20 into 30. Okay, so it will be 500 into 30. 500 3 5s are 15, 00. So 1500 joules. Okay, 1500 joules is the answer. Be careful while multiplying. Okay, 25 into 2 is 50, another 0 is there, so 500. Okay, 500. Now 5 into 3 is 15, and how many zeros are there? Oh sorry, 500, right? So 500 means it will be another 0. 500 into 30, right? So how many zeros? 1 2 3 zeros. 1 2 3 zeros. So they, see, if you just calculate, after calculating, if you just cross check it once, even if you have made some mistakes, there is a chance that you can rectify that mistake. Okay, so it will be 15,000 joules, not 1500. Okay, now let's move on to the next question. A rectangular loop carrying current I is situated near a straight conductor XY. So a rectangular current carrying loop I is situated near a straight conductor XY. Okay, if a steady current I is established in the conductor will. Okay, so a rectangular loop and conductor, so both are kept near to each other. Okay, now current through this is fixed, remain stationary, move towards the side AB of the loop, move towards the side AB of the loop, rotate about its axis. So what will happen to the electric field is established in this is constant. Okay, and here is also a current flowing. Now in this case, what will happen? Let us understand what will be the direction of force. Okay, so first of all, if you see these two currents are perpendicular. So perpendicular currents will not be affected by any of this current flowing through it, right? They will not attract, not repel. Now these two currents are parallel in the same direction. Parallel in the same direction means they will feel some force of attraction. They will feel some force of attraction, whereas so parallel two currents carrying in the same direction, they feel the force of attraction, and if the current direction is opposite, then they feel a force of repulsion. So this arm will feel a force of repulsion. Now these two are very close, okay, compared to this arm. So the net force acting on this loop will be in this direction. Why? Because this distance is smaller. So this is say D1, this is say D2, and this force is basically inversely proportional to the distance. So that means closer it is, higher the force, further it is, less is the force. Okay, so the force between two parallel current carrying wire is inversely proportional to the distance between the wires, right? So here we can say that because it is inversely proportional to the distance, it will experience a force in this direction, and this will experience a force in the opposite direction, but the net force will be towards the conductor. So it will be moved towards the side AB of the loop. So it will move towards the side AB of the loop. Obviously that is correct. So move towards the side AB of the loop. So it will move in this direction, and it is a very simple logical question, but you have to apply certain level of understanding. Now let's move on to the assertion and reason based question. Assertion: magnetic field lines never intersect each other. Yes, if they intersect, the compass needle would point towards two direction, which is not possible. Yes, that is also correct. So if two magnetic field lines, they intersect each other, so when you keep a magnetic needle, this line will say, okay, point towards me. This line will say, no, you only can point towards me only. Okay, so the compass needle will switch between two position, which is not possible. Compass needle will have to be a single directional position. Okay, unless if the magnetic field is uniform, definitely the compass needle will point only in the one direction. So both A and R are true, and R is the correct explanation of A. Yes, correct explanation. So option A is the correct answer. Now let's move on to the 2 marker section. A person suffering from presbyopia needs bifocal lenses. If he needs 2 lenses of power -4 diopter and +2 diopter, which one of these 2 lenses is for the correction of the distant vision, and what is the focal length? So first of all, we have 2 persons suffering from presbyopia. Okay, presbyopia means he cannot see clearly the nearby objects, neither he can see distant objects. So both near points and far points both have changed. Far point has come from infinity to some distance, and near point has shifted from 25 centimeter to further to far away. Okay, so that is why he cannot see both of the points clearly. So what he needs a bifocal lens, right? Now the distant object is basically corrected by concave lens, right? Concave lens having a negative power. So a concave lens of power -4 diopter is used to correct distant vision. So whenever you are suffering from say myopia, Okay, myopia means when you cannot see distant object clearly, distant vision is blurred. So to correct that distant vision, we use concave lens. Okay, so concave lens, how do I know that -4 is concave lens? Because of this negative sign. So negative sign means the focal length of the lens is negative, so that means it is a concave lens. Concave lens has a negative power, convex lens has a positive power. Okay, so if you are wearing specs like me, and if you are not able to see distant objects, then your power will be negative. Okay, negative 1, 2, 3 like that, -1. What is your power? We say -1, right? So not my power, it is the power of my glasses, right? So power of the glasses negative means you are wearing a concave lens. Okay, so concave lens is -4 diopter, and focal length is basically in terms of meters. If you are calculating in terms of meters, the focal length is basically given by 1 by P, but as I said, this is in terms of meters, but if you want to convert it into centimeter, it will be 100 by P centimeters. Okay, this is in meters, right? So 100 by P is -4, so it will be -25 centimeters. Okay, or 0.25 meters. You can find it in terms of meter as well, no problem. Okay, negative sign indicates it's a concave lens. Okay, if you want, okay, I don't want to use this, I want this original formula only, 1 by P, that is 1 by -4, you will get -0.25, but in this case the answer will be in meters. This is also quite acceptable answer for this question. Now let's move on to the next part. Two wires A and B of the same material having lengths and diameters 0.2 millimeter and 0.3 millimeter respectively are connected one by one, having same lengths. I think having same length and diameters of 0.2 millimeter and 0.3 millimeter respectively are connected one by one in a circuit. Which one of those two wires will offer more resistance to the flow of the current circuit? Justify your answer. So we have two wires. One is A having 0.2 millimeter diameter. Okay, length is same, and we have another wire B which is same length but diameter of 0.3 millimeter. So this is diameter is 0.2 millimeter and diameter of this wire is 0.3 millimeters. Now which one will have a higher resistance? So we know that resistance R is basically given by rho L by A. Okay, and also we know that area is equal to pi r square, circular cross section, or pi d by 2 whole square, or pi d square by 4. Right, now if you put that back in the equation, so r equals to rho L by pi d square by 4, or 4 rho L by pi d square. So we can see that resistance is inversely proportional to the square of the diameter. So whoever has the higher diameter, they will have less resistance. Whoever has less diameter have more resistance. Okay, so in this case the wire A will have more resistance compared to wire B, because the diameter of wire A is more diameter of wire A is less than diameter of wire B. So more the diameter, less is the resistance. Okay, so we can justify, while justifying we have to do this calculation and show that resistance is inversely proportional to the square of the diameter. So if the diameter is less, resistance is more. If diameter is more, resistance is less. Okay, so more resistance is basically 2 millimeter wire. Okay, now next question. Now we have moved on to the 3 marker section. Define the term power of accommodation of the human eye. What happens to the image distance in the eye when we increase the distance of an object from the eye? Name and explain the role of the part of the human eye responsible in this case. So let's see the answer. So the power of accommodation refers to the ability of the eye lens to adjust the focal length to focus on the objects at varying distances. Okay, when the distance of the object increases, the image distance remains constant as the image is always formed on the retina. The ciliary muscles adjust the lens curvature, allowing clear vision for both distance and nearby objects. So you have to remember that in case of our, why the human eye is so beautiful is because suppose this is human eye. Okay, this is the eye lens. Now the distance between eye lens and the retina is always fixed. Okay, unlike for our fixed lens, focal length lenses, where you can change the screen length. Okay, you can make the screen little bit further, or you can adjust the length of the screen, okay, based on whatever you are seeing. This distance for our human eye is fixed. Okay, so how can we see a nearby object? Now we know that the lens equation is 1 by v minus 1 by u is equal to 1 by f. So based on the whatever u we are using, okay, v should vary, but in this case the v is always constant. V is always constant. Okay, so the distance between the lens and the screen is same, that means V is always constant. So how can we adjust for different u? The only way to do that is by changing the focal length of the eye. So the focal length of the eye is being changed by a component called ciliary muscle. Ciliary muscle can contract or expand based on whatever is required from you. Okay, it can be very thin and increase the power of the lens. Okay, it can be very thick, it can be very thin and decrease the power of the lens, and it can show you the closer objects, or it can be normal and the eye lens will be thicker and you can see distant objects clearly. Okay, so by adjusting the focal length of your eye lens, you can see both nearby and close objects clearly. This is a food chain question, so this is not physics. Okay. So I think somehow one question may be missed in this question paper. I'm sorry. Okay, if you find that question from the question paper, you can mention in the comment below. I will try to do the correction. Okay, now let's see the 5-marker question. The variation of image distance v with the object distance u for a convex lens is given. So how the object distance and image distance is changing for a given lens is shown, okay, in this vu versus v diagram. Table. Okay, analyze it and answer the following questions. Without calculation, find the focal length of the convex lens. Justify your answer. So they have given you, this is a convex lens. Okay, so this is a convex lens. So as you can see, without calculation, how can you do that? You have to do a little bit of calculation. That is, for convex lens, when the object is kept at 2f, the image is also formed at 2f on the other side of the lens, right? So if you see here, the object distance is minus 50 centimeter and the image distance is plus 50. So image is obviously real and of the same size. So that means this is actually corresponds to the 2f focal length. This corresponds to the 2f focal length. So if this corresponds to the 2f focal length, that means focal length must be half of it. So small calculation that you have to do is divide this 50 by 2. So you can say 25 centimeter is definitely the focal length of the lens. By observing the table, you can say, okay, 25 centimeter is the focal length of the lens, right? Which observation is not correct? Why? Draw a ray diagram to find the position of the image for this position of the object. Okay, now if you see, we know that when the object is kept at a distance less than the focal length, image is formed, that is a virtual image, which is on the same side of that of the object, right? So in this case, if you see, object distance is minus 15 centimeter and image distance is shown plus 37.5 centimeter. Which is not possible. This image distance has to be negative. Image distance positive is not possible because the distance in this case is less than that of the focal length. So if the image distance is less than that of the focal length, the image distance has to be the object distance is less than that of the focal length. If the object distance is less than that of the focal length, that means image will be on the same side of the object and it will also be negative, right? The sign has to be negative. So definitely this is not possible. So this is the incorrect observation. Now you have to draw the ray diagram diagram for virtual image. Find the approximate magnification when u is equal to minus 30 centimeter. So u is equal to minus 30 centimeter. So approximate, why approximate? You can find direct magnification. Okay, so u is minus 30, v is given as plus 150. So you can easily calculate the magnification is given by 150 divided by 30, minus 30 actually, so it will be minus 5. So the magnification is minus 5. Okay, so inverted and real and enlarged. Okay, there is some OR question as well. Define the principal axis of lens. Okay, draw a ray diagram showing the behavior of a light ray parallel to the principal axis of the concave lens. The focal length of a concave lens is 20 centimeter. Calculate the distance from the lens in the placing a 5 meter tall object to form an image at 15 centimeter. Also calculate the image size. So this is basically 1 and 2 ka OR question. Let's see the first part ka answer. When the object distance is equal to the focal length, the image distance is very, very large. Based on the table, the focal length is approximately 25 centimeter. Okay, they are saying that, so when the object is placed at the focal length, the image distance is very, very large. So basically, even though you can see the image distance is very, very large, you cannot guess that from that perspective. Only way you can guess that is when the object is placed at 2f, the image is exactly at 2f. From there only you can calculate for this given table. Okay, so the first part I think is not correct. The explanation is not correct. Okay, it was taken from the standard answer given by the board. So that's why we are not editing it. We are editing whenever it's required. So in this case it is unfortunately incorrect. So when the object is kept at 2f, the image is also formed at 2f. That is the answer. When object is at 2f, image is also at 2f, but on the other side of the lens. Okay, so that is why that is our logic to answer this question. Now observation with u is equal to minus 15 centimeter shows a real image, but it should be a virtual. The error is due to the incorrect placement of the object. Okay, incorrect placement of the object or incorrect placement of the sign. So error is basically the negative sign of v is not there, so that means it is not possible. Now magnification m is equal to v by u, which is equals to minus 5 is the question. If you answer it, you will get full marks. Now let's see the OR question. Okay, the principal axis is the line passing through the optical center and center of the curvature. In a concave lens, rays parallel to the principal axis appear to diverge from the focus. Okay, so rays appear to diverge from the focus. Also in the previous case, you have to remember that you have to draw a diagram. Okay, so that diagram where you are showing that this is f, this is 2f. Okay, you kept an object over here. So the parallel rays after passing through the focus, another is going like this, and if you trace them back, you will get some image. So this is the correct image of the object. Okay, and whenever you draw a ray diagram, don't forget to put the arrows. Okay, arrows are very, very important. Okay, this is the way you have to draw the diagram. Similarly, here also there is a ray diagram for concave lens. I am not going into that. Now using the lens formula, 1 by f is equal to 1 by v minus 1 by u. F is given minus 20, convex lens. Concave lens, v is given minus 15 centimeter, u is given, you can calculate u to be minus 60. Okay, and from there you can calculate the magnification to be 1/4. So image size is 1.25 centimeter. So if you calculate u, from there you can calculate the magnification, from there you can calculate the image size as well. Now let's move on to the 4 marker section. Study the following circuit and answer. Find the total resistance between points A and B. Find the total resistance between the point A and B. Okay, so here we can see that 3 resistances connected in series. So 4 plus 6 is 10, 10 plus 16 is 26. So between A and B it is 26. Easy. Okay, next is find the resistance between point B and C. Now we have to find the resistance between B and C. Here we can see 2 8 ohm resistances connected in parallel. How many resistances? 2 resistances. Are they equal? Yes, they are equal. So what is the formula? What is the shortcut I taught you to calculate the equivalent resistance? 8 by 2. So this will be 4 ohm. Can you use that in the exam? If you explain it properly, yes, you can use it. Okay, or you can, if you don't want to use it, R1 R2 by R1 plus R2 is always there. Okay, that is a easier formula. So in this case, even if they were different, you can use that formula. Now find the resistance between point B and C. So B and C is also done. Calculate the current drawn from the battery. So now you have to calculate the current drawn. To calculate current drawn, you have to find the total resistance. So total resistance is 26 plus 4 because they are connected in series. So 26 and plus 4 is 30 ohm. So 6 divided by 30, that is 1/5 will be the current. Or there is a OR question, which has more potential difference, 16 ohm resistor or the parallel combination of 2 8 ohm resistors justify. We will see that. Okay, the last part we will see that. Now let's see step by step. So total resistance RAB is 26 ohm, parallel resistance 1 by R. So whatever I have done, they have done little bit in a longer way. So it is 4 ohm. Okay, total resistance is 30 ohm, current is equal to 6 by 30, that is 1 by 5 or 0.2 ampere. Okay, so this is, in my opinion, is easier. If you want to do this OR question, it is slightly difficult. So potential difference across 16 ohm resistor. Now you have to calculate the current, then you can use this to calculate the voltage. So potential difference across 16 ohm resistance is 0.2 into 16, that is 3.2 volt. Parallel combination, what is the total resistance of the parallel combination? Total resistance is 4. Okay, so 4 into 0.2, that will be 0.8 volt. So the 16 ohm resistors has a higher potential difference compared to the resistance in parallel. Okay. Now, this paper is not yet over. There is a visually challenged question. I think question is missing here. The visually challenged question is missing. So visual challenge part is missing in here. So by anyway, I will conclude this lecture here, and if you have any questions, please mention that. I will try to give you this PDF along with the question paper so that you can check whatever is the visually impaired question, if any. Okay, thank you for watching.